Steve, if I told you that your next car might make decisions by considering every single possibility in the universe all at the same time, would you say I've been watching too much sci-fi?
I'd say you're finally catching up with the quantum physicists, Claire. It sounds like a paradox, doesn't it? Doing infinite things at once? But that's precisely the strange and wonderful world we're stepping into with quantum computing in automotive.
Strange, wonderful, and frankly a bit mind-bending for my morning coffee. So grab your mug, whether you're sipping or catching up later, because today we're diving into something that sounds impossible but is already happening in automotive labs around the world.
I'm Steve, and this is Claire. We're part of the Auto Agentic team, and this is Auto Intelligence, where we explore the trends reshaping how we design, build, and drive the cars of tomorrow.
New episodes drop every Tuesday, Thursday, and Saturday. And honestly, we're blown away by how this community keeps growing. Thank you for making auto intelligence part of your routine.
So, for those of us who aren't quantum physicists, and let's be honest, that's most of us, what does this actually mean for the car in our driveway or the one we'll be buying in 10 years?
Think more about a car that doesn't just avoid an accident, but preempts the conditions for an accident miles down the road. Or a battery that could potentially design its own perfect chemistry. Or logistics for an entire city's traffic flowing like a perfectly choreographed ballet.
Okay, ballet I can understand. But it sounds like you're saying this isn't just about making cars faster or smarter in the way we currently understand smart. This is a different kind of intelligence altogether?
Exactly. It's like upgrading from a very fast bicycle to a vehicle that can navigate multiple dimensions. Today on Auto Intelligence, we're not just looking under the hood. We're peering into the very fabric of reality to understand how quantum mechanics could rewrite everything we thought we knew about driving.
Let's start with the basics, because quantum computing sounds like magic until you understand the science. Claire, what exactly is a quantum computer, and why should it matter to someone buying their next car?
Think about a normal computer bit, Steve. It's like a light switch, either on or off, simple. A quantum bit or qubit. Imagine that light switch, but it's also the dimmer, the color of the bulb, and the song playing on the radio, all at once, until you actually look at it. It's holding a universe of possibilities in a single point.
So for a car, instead of calculating one route, it's like it's already driven every conceivable route in a ghostly parallel and then picks the absolute best one in an instant?
Precisely. It's not just faster calculation, it's a fundamentally different way of thinking. But here's the reality check. We're still in what researchers call the noisy intermediate scale quantum era. Current quantum computers have limited qubits, high error rates, and lack the robust error correction needed for the most complex problems.
Which is why most practical applications today use hybrid approaches. Classical computers handling the bulk of the work, while quantum processors tackle specific problems where they might offer an advantage.
And that's exactly where we're seeing the most interesting automotive research. Volkswagen's pioneering work with D-Wave systems, which began around 2017, explored quantum traffic optimization in cities like Lisbon and Beijing. While the specific results vary by project, the potential for significant improvements in urban mobility is compelling.
What fascinates me is that this isn't theoretical anymore. These are real pilot projects testing whether quantum algorithms can solve optimization problems that have bottlenecked cities for decades.
And the early results are promising enough that VW has continued expanding their quantum research, including partnerships with Google Quantum AI and more recently with IQM Quantum Computers for battery simulation studies.
Let's dig into autonomous vehicles, because this is where quantum computing could be truly transformative. Think about what an AV has to process in real time. High-resolution camera feeds, LiDAR data, radar inputs, GPS information, vehicle-to-vehicle communications, traffic patterns, weather conditions.
The computational load is staggering, and here's where quantum gets interesting. Instead of processing each piece of information sequentially, quantum algorithms could potentially handle this complexity more efficiently through superposition and quantum interference.
Researchers are exploring quantum support vector machines for complex classification tasks relevant to automotive data. For an autonomous vehicle, better object detection could mean the difference between correctly identifying a pedestrian stepping into the street or missing them entirely.
Though we should be clear, these are currently in the experimental and theoretical stages, not yet deployed in production vehicles. But the potential is there.
Route planning is another area where quantum shows promise. An AV needs to factor in traffic, weather, road conditions, energy consumption, passenger preferences, and potentially hundreds of other variables to find the optimal path.
And this is where the research gets really practical. BMW is actively exploring quantum applications through their partnership with Pascal, focusing on metal-forming processes and solving complex differential equations. They're also investigating quantum-enhanced digital twins.
Digital twins, virtual replicas of vehicles and components. Currently, these use classical simulations, but the long-term vision is that quantum simulations could one day enhance them, allowing for unprecedented accuracy in modeling complex phenomena.
Instead of building physical prototypes and running expensive tests, you simulate thousands of scenarios virtually. BMW could test how a vehicle performs under different conditions, optimize for aerodynamics, safety, noise reduction, all before building a single physical prototype.
Which brings us to one of the most exciting research areas, materials science and battery development. This is where quantum computing really shines because it's literally simulating the quantum behavior of atoms and molecules.
Ford's collaboration with Quantinuum is a perfect case study here. They're using quantum chemistry simulations to understand charge and discharge mechanisms in lithium-ion batteries at the molecular level.
But let's be realistic about current capabilities. Current quantum simulations for batteries are limited to small molecules or specific aspects of chemical reactions due to hardware limitations. Simulating entire complex battery systems is a long-term research goal.
Still, the potential is compelling. When you can simulate exactly how lithium ions move through different materials, you could potentially design better electrolytes, more efficient cathodes, and safer battery architectures.
Hyundai and IonQ are taking a similar approach, using quantum simulations to optimize electrolytes and catalysts for advanced EV batteries. The vision of customized battery designs optimized for specific vehicle types is fascinating.
I love that concept, moving away from one-size-fits-all solutions toward precision design. A battery for a long-haul truck needs different characteristics than one for an urban delivery van or a high-performance sports car.
And the implications go beyond just better batteries. Toyota has explored quantum applications through partnerships with D-Wave systems, including research into traffic signal optimization. Even suppliers like Bosch are investing in quantum startups like Zapata Computing.
What strikes me is how this represents a fundamental shift in how we approach engineering problems. Instead of trial and error experimentation, we're moving toward precision design based on quantum-level understanding of materials and systems.
Speaking of systems, let's talk about supply chains, because this is where quantum computing could deliver some of the most immediate value. The automotive supply chain is incredibly complex. Thousands of suppliers, just-in-time inventory, global logistics networks.
And even small inefficiencies cascade into major problems. A delayed shipment of semiconductors can shut down an entire production line. Excess inventory ties up capital. Poor demand forecasting leads to either shortages or waste.
The research into quantum algorithms for supply chain optimization is promising. Companies are exploring applications like supplier selection, logistics routing, and inventory management where quantum computers could potentially evaluate multiple complex variables simultaneously.
McKinsey and Company projects that quantum computing could deliver $2 to $3 billion in economic impact to the automotive sector by 2030, with much of that early value expected to come from solving complex optimization problems.
That's a substantial projection, and it reflects something important. Quantum computing isn't just about breakthrough technologies like autonomous vehicles or revolutionary batteries. It's also about making existing processes more efficient. You're listening to Auto Intelligence, brought to you by Automaker,
the platform transforming automotive retail with intelligent, human-centered AI. It's fascinating, Steve. While we're talking about quantum computing pushing the boundaries of what's possible in research and development, Automaker is focused on practical AI solutions that help dealerships thrive today.
Exactly. From lead nurturing and inventory optimization to service scheduling and customer experience enhancement. What sets Automaker apart is their consultative approach. They don't just deliver technology, they deliver trusted guidance on navigating the complexity of AI implementation in real-world automotive retail environments.
In a way, they're doing for today's dealerships what quantum computing might do for tomorrow's vehicles, making sense of vast amounts of data to create better outcomes. Learn more at autoagentic.ai.
Now back to quantum computing. Claire, we've talked about the research potential and pilot projects, but I think we need to address the current reality and limitations.
Absolutely. Because while these research initiatives are impressive, we need to be honest about where we are. Current quantum computers are powerful for specific problems, but have significant limitations.
Most practical applications today use those hybrid approaches we mentioned. The quantum processor handles specific optimization tasks, while classical computers manage the overall workflow.
And there's the talent challenge. The competition for quantum computing specialists is fierce. Automakers are competing not just with each other, but with tech giants, financial firms, and research institutions for a very limited pool of experts.
This is creating interesting dynamics in the industry. We're seeing more partnerships between automakers and quantum computing companies, more investment in academic research, and more emphasis on upskilling existing engineering teams.
The security implications are fascinating too. Quantum computing threatens to make current encryption methods obsolete, but it also enables quantum-resistant cryptography. For connected and autonomous vehicles, this could be crucial.
Imagine the cybersecurity requirements for a fully autonomous vehicle. It's not just about protecting personal data, it's about ensuring the safety-critical systems can't be compromised. The primary industry response right now is developing post-quantum cryptography, new classical algorithms designed to be secure against attacks from both classical and quantum computers.
But this raises broader questions about data privacy and algorithmic transparency. As these systems become more powerful and more complex, how do we ensure they're making fair and unbiased decisions?
That's a critical point. The complexity of quantum algorithms adds another layer of opacity to AI systems that are already difficult to interpret. We need robust frameworks for validation, testing, and explainability.
Let's shift to the future outlook, because I think that's where things get really intriguing. What are you watching for in the next few years?
I'm particularly excited about the convergence of quantum computing with other emerging technologies. Quantum-enhanced AI for autonomous vehicles is just the beginning. We're starting to see research into quantum sensors that could dramatically improve vehicle perception systems, though their widespread use in mainstream vehicles is still speculative.
The manufacturing applications are intriguing too. BMW and Pascal's work on quantum processors for metal forming simulations could eventually lead to quantum-optimized manufacturing processes with unprecedented precision.
The material science applications will likely accelerate as quantum hardware improves. As we can simulate larger, more complex molecular systems, that could lead to breakthroughs not just in batteries, but in lightweight alloys, sustainable materials, and even self-healing composites.
I'm also watching the business model implications. Quantum computing could enable new services and revenue streams, real-time mobility as a service platforms, dynamic pricing based on complex optimization, on-demand logistics networks.
That's a great point. We tend to focus on the technical capabilities, but quantum computing could fundamentally change how automotive companies operate and compete.
The standardization efforts will be crucial too. Cross-industry collaborations are essential for developing quantum applications that can scale across the automotive ecosystem.
And we're likely to see more specialization. Different quantum computing approaches, gate-based systems, quantum annealers, photonic quantum computers, each have different strengths. The industry will probably develop expertise in specific applications rather than trying to do everything with one approach.
Looking at the competitive landscape, it's interesting how this is reshaping industry relationships. Traditional automakers are partnering with quantum startups, tech companies are entering automotive markets, and new ecosystems are forming around quantum applications.
The pace of research development is remarkable too. Just 5 years ago, quantum computing was primarily an academic curiosity. Today, we have automakers running research pilots and seeing promising early results.
And the investment levels reflect that momentum. When you see companies like Volkswagen, BMW, Ford, and Toyota all making significant quantum computing investments, it signals that this isn't speculative research. It's strategic preparation for competitive advantage.
Which brings us back to the talent race we mentioned earlier. The companies that can attract and develop quantum expertise now will have significant advantages as the technology matures.
It's also worth noting that this isn't just about large automakers. Quantum computing as a service platforms are making quantum hardware accessible for experimentation, though effectively utilizing these systems still requires significant expertise.
That democratization aspect is important. It could level the playing field in some ways, allowing smaller companies to leverage these capabilities without massive infrastructure investments.
As we wrap up, I think it's worth emphasizing that we're still in the early stages of this transformation. The research projects and partnerships we've discussed are laying the groundwork for what could be transformative applications.
Absolutely. Experts suggest a 15 to 20-year horizon for broadly useful quantum computers in many sectors. The companies that understand and prepare for this shift will be the ones that thrive.
And for our listeners, whether you're in automotive retail, manufacturing, or just fascinated by technology, this is a trend worth following closely. The implications extend far beyond just better cars. We're talking about more efficient transportation systems, reduced environmental impact, and new possibilities for mobility.
The intersection of quantum computing, artificial intelligence, and automotive innovation represents one of the most exciting technological frontiers we've seen. The research happening today is laying the foundation for tomorrow's breakthroughs.
So, the quantum revolution in automotive isn't a distant dream, Steve. It's a research challenge being tackled in labs right now with the potential to fundamentally change how we think about transportation.
And it makes you wonder, what aspect of driving or even our cities do you think quantum will transform first? We'd love to hear your thoughts.
Thanks for joining us on Auto Intelligence. This episode was produced by the team at Automaker, the most human AI company in automotive retail. We don't just deliver technology, we deliver trusted guidance for navigating the future of automotive innovation.
Learn more at autoagentic.ai, and we'll see you next time as we continue exploring the trends reshaping the automotive industry.
The road ahead is uncertain, but with quantum, it's certainly going to be an extraordinary ride. Until then, keep innovating.